Hello students, welcome back to my YouTube channel Civil Edu Next. Myself Maitri Dave, Assistant Professor at LJ Institute of Engineering and Technology. Today we are going to discuss about angular measurement. So we are going to start our lecture number 2. But before that, let's discuss what we have learned in previous lecture. Basically, we have discussed the first topic, which is introduction of traverse surveying. In the second topic, we have learned different instruments which are used for the angular measurement like compass. Again, it can be of two types, prismatic compass and surveyor compass. And lastly, we have seen the temporary adjustment of compass. It means the 3 steps. Which are that 3 steps? They are the centering, leveling and then focusing, right? So that we have already learned. So in today's lecture, we are going to discuss about our first topic, in which we are going to know what are the terms which are used related to angular measurement. And after knowing the terms, what are the methods that we use for the measurement of the bearing, right? So without wasting much time, let's get started with our first topic, which says the terms related to angular measurement. So basically, there are various terms used like meridian, declination, deep of magnetic needle and different lines, right? So first, let's understand what is meridian. So generally, a meridian is something in which a bearing of line is always measured in a clockwise direction with respect to some reference line or direction. This fixed reference line is known as meridian. If I simply say this, it is very difficult to understand, right? So here assume this is the earth and this is the north pole of this earth and this is the survey line on earth, survey line AB. Now, if I have to measure the angle in clockwise direction, but here the concept is with reference to some line or direction. So here our reference line or direction is our north pole. So I can say it is my meridian. Is it clear, everyone? It is the reference line or direction which is known as the meridian, not the angle. So in simple words, I can say a reference line is considered as a meridian, right? But when I want to write its definition, the first term itself, which says a bearing of a line. So now what is a bearing of a line? So generally, the horizontal angle made by survey line with the magnetic north or a fixed reference line is known as the bearing of a line. So here our reference line is north pole and it is known as the meridian. So with reference of that north pole, we are going to take a clockwise direction horizontal angle to our survey line, which is survey line AB. That is clearly shown in this figure, so that angle is known as the bearing of line. So again, in simple words, I can say bearing of line is nothing but simply the angles. So here, two basic terms, something which is known as now measuring bearing of a line. A line means a survey line. And now we are talking about survey lines because here in a traverse survey, we are saying it is a closed loop of survey line, right? I hope you are connecting all these terms, right? Again, survey line having some angle with reference to something. It means our reference is always known as the meridian. So two terms is very basic and you should know its meaning. It means reference line is meridian and angle is the bearing of line, right? Now, there are various types of meridian, right? It means various reference line available. Basically, it is of 3 types, in which first is the true meridian, second is the magnetic meridian, and lastly the arbitrary meridian. Now say for the example, this is the earth surface and this is the true north, right? Again, this is the magnetic north of earth. and this is my survey line AB. Here, if I talk about the reference line as a true north, it means an imaginary line passing from the north and south pole of the earth, that is known as the true meridian, right? Now, with respect to this reference line, it means with respect to true meridian, I want to identify the bearing of line. Now, bearing of line means the angle. Angle of what? Angle of my survey line. My survey line AB as shown in this figure. It means in clockwise direction, I am trying to find the angle. That angle is now known as the true bearing of line as it is calculated with reference to true meridian. Is it clear, everyone? Okay. Now, let's discuss the magnetic north line. It means regarding magnetic meridian. Now, magnetic meridian is something which is an imaginary line passing from the magnetic field of that particular place. Now, a magnetic field varies with place to place. So that here for AB survey line, magnetic north is something look like this. So, a line passing from the magnetic field of that place is considered as the magnetic meridian. Now, if I want to calculate the angle, it means the bearing of line with reference to magnetic meridian, it is something like this. And that is known as the magnetic bearing of line. So, here you have to keep in mind that if I talk about the true meridian, or it is also known as the azimuth, so it is the line which passes from the north and south pole of the earth. And when I talk about the magnetic meridian, it is the line passing from the magnetic field of that particular place. And whenever you calculate the angle with respect to the true meridian, it is always known as the true bearing of line. And when you measure the angle with respect to magnetic meridian, it is always known as the magnetic bearing of line. So, till now we have discussed these two types of meridian. But what about the last one, arbitrary meridian? So, when you don't have any idea about true meridian or magnetic meridian, it means the true north or the magnetic north of earth. So, at that time, you are assuming any particular object's direction as your reference direction. I am saying any object's direction, not the object, right? So, at that time, you are considering any direction as your reference direction, and that is known as the arbitrary meridian. And whenever with respect to that direction, you are going to take angle for your survey line, that is known as the arbitrary bearing of that line. So that is all for types of meridian, right? Now, let's move to the next term related to the angular measurement, which is declination. Now, the question comes, what is declination, right? So, first, see, this is the true north. It means the true meridian. This is the magnetic north. It means the magnetic meridian. Now, I am saying the angle between these two reference lines is known as declination. It means, in simple words, I can say the horizontal angle between the true north and the magnetic north at the place at the time of observation is called as the magnetic declination, or in other words, I can say the horizontal angle between the magnetic meridian and the true meridian is known as the magnetic declination. So generally, when I am talking about the angles with respect to survey line, that is something different. That is the bearing of line, right? But when I am talking about the angle between the two reference line, that is always known as the declination. But again, it can be of two types. It can be of declination west and declination east. Now let us understand how. It is the true north, which is true meridian. It is the magnetic north, which is the magnetic meridian. And suppose this is my survey line AB. Now you can see over here, from true north, I am measuring the angle to my survey line, which is known as the true bearing. And from the magnetic north, I am measuring angle with respect to my survey line is my magnetic bearing. And as I said, angle between these two reference lines, it means the true north and the magnetic north, is known as the declination. But here I am mentioning it as a declination west. Why? Because as we know, true north, true south, east and west. Here you can see our magnetic north is with respect to west. So the angle is in direction with the west. So it is known as the declination west. So I can say when the north end of the magnetic needle is pointed towards the west side of the true meridian, the position is called as a declination west, theta w, right? Now, if you see over here in this figure, three terminologies are there. First is the true bearing, second is the magnetic bearing, and third is the declination, right? Here it is specifically declination west. Now, three terminologies are there, and if I want to find a correlation between these three, then you can say for declination towards west, I can say the true bearing. It means with reference to true north, the angle made to my survey line, that is true bearing, is calculated by simply minusing the value of declination from the magnetic bearing. As you can see in this figure, magnetic bearing is the total angle and the true bearing is the inside angle. It means the true bearing is equal to magnetic bearing minus declination. So I can say whenever the declination is in west, at that time I have to simply minus my declination to find the true bearing of that line. That is the concept, right? Now let's understand declination east. So as I said, that is my true north, it means true meridian. Magnetic north means magnetic meridian, my survey line AB, true bearing of line, magnetic bearing of line, and this is my declination east. In west, magnetic north is something in west direction, but now my magnetic north is in east direction. So I can say when the north end of the magnetic needle is pointed towards the east side of the true meridian, the position is called as declination east, theta east. And again, you can see on the screen that true bearing of line is now the total angle. So I have to identify my declination and simply add it to my magnetic bearing to get my true bearing of line. So I can say in simple words, true bearing of line is equal to magnetic bearing plus declination, right? Here, whenever declination east is there, I have to simply add to it to my magnetic bearing, right? So this is the concept for declination east. Now, let's go to the next term related to angular measurement, which is dip of magnetic needle. Now, what is the dip of magnetic needle? So here on screen, you can see one figure, right? So the magnetic needle dip on of its side towards the pole due to the magnetic influence of the earth. It means here on screen, you can see a horizontal plane is there and my magnetic needle is making angle with this horizontal plane. That angle is known as the angle of dip, and it is only possible when my magnetic needle is attracted to the pole of earth, right? So the angle made by deflected needle with the horizontal plane is known as the dip of magnetic needle, right? So now let's understand the different lines, right? So there are three types of lines, in which first one is the isogonic line. It means a line passing through the points of equal declination is known as the isogonic line. Now what is declination? So declination is the horizontal angle made with two reference line, right? So when the value is equal, at that time we are trying to join that point having equal declination. That line is known as the isogonic line, right? Next is the agonic line. It means a line passing through the points of zero declination is called as the agonic line. But now, what is zero declination? Zero declination means there is no angle. No angle between true north and magnetic north. It means whenever my true north is my magnetic north, there is no such angle. At that time, line passing from that kind of points is known as the agonic line. Generally, this kind of condition create on the extreme point of the Earth's pole, North Pole and South Pole. At that time, the true north and the magnetic north is same, right? And last is the isoclinic line. Now, these are the line passing through the points of equal dip. Now, I am saying word dip. Now, what is the dip of needle? That you know that a needle making angle with the horizontal plane, right? So, having the same value of equal dip and a line passing through it is known as the isoclinic line. So that is the concept, right, for different lines. Now let's understand our second topic, which is measurement of bearing. So generally, measurement of bearing can be of three types. First is the whole circle bearing, second is the quadrantal, and third is the reduced bearing. So now understand what is whole circle bearing. Generally, a whole circle bearing is a system in which a whole circle is to be considered. It means a range of angle is from 0 degree to 360 degree. Here on screen you can see that on top at north it is 0 degree, on east it is 90 degree, on south it is 180, on west it is 270, and again on north it is 360. It means completing a whole circle, right? According to that, it is also known as the WCB system. Here a horizontal angle with respect to magnetic north is considered. It means only with respect to north we are taking the angles. Here you can see, again I can divide this circle into different quadrants. Here the first quadrant having the value in between 0 to 90 degree, the second quadrant is having the value between 90 to 180 degree, and the third quadrant having the value between 180 to 270, and lastly the fourth quadrant having the value between 270 to 360, right? But it is only possible when I am taking angle with respect to north only and in clockwise direction. Otherwise it cannot be possible. So that I can get the angles range from 0 degree to 360 degree. That is the concept of whole circle bearing. Okay. So now let's move to the second type, which is quadrantal bearing. Now what is a quadrantal bearing? So in its name it is suggested we are focusing to quadrants now. It means here on screen you can see a north, south, east, west is there, right? But when I divide a circle into the quadrants, it means each quadrant having the value of 0 to 90 degree. It means to achieve that range, I have to calculate angles in clockwise as well as in anti-clockwise direction. At the same time, with respect to north or with respect to south, whichever is nearer to my survey line. Now what I am saying, for that see in this figure. Here when the north is marked, consider it to be a 0 degree. Again at south, consider it to be 0 degree. Why? Because we want the value of quadrant as 0 to 90. It means the east and west should be of 90 degree, right? So the first quadrant is known as now northeast quadrant. Now we can see over here it is mentioned as north 45 degree east. It means it is denoted with the northeast to mention its quadrant, because I am talking about in terms of quadrant, and again that value 45 is again in between the range of 0 to 90 degree, right? That is my first quadrant. If my survey line is at 45 degree in the first quadrant, it means with respect to north I have to go in the clockwise direction as shown in this figure. But if my survey line is go through the second quadrant, as you can see the second quadrant is quadrant S to E. It means if I talk about the value south 15 degree east, then I have to go in anti-clockwise with respect to south, because now east is the 90 degree and south is the 0 degree. So I have to measure from 0 to 90. So south to east in anti-clockwise direction. That is the concept for the quadrantal bearing for second quadrant. If I talk about the third quadrant, you can see over here, third quadrant is of southwest. It means in the clockwise direction, I have to go for south to west. Here you can see on screen, south 45 degree, west is the survey line, right? And for fourth quadrant, you can see I have to go in anti-clockwise direction from north, because my survey line is nearer to north now. So whenever it is about first and fourth quadrant, I have to deal from north, and whenever it is in second and third, I have to go from the south, because it is the only way which makes my quadrant's value in the range of 0 to 90 degree, right? So I can say whenever horizontal angle with respect to magnetic north or south, whichever is nearer, is considered for taking the bearing of line, is considered as the quadrantal bearing system. And it is only possible when we go for the clockwise as well as the anti-clockwise direction to achieve the values in the range of 0 to 90 degree, right? So that's all for the quadrantal bearing. Now let's understand the difference between the WCB system and the QB system. So here you can see on screen, in WCB system, the horizontal angle is made by a line with the magnetic north and in clockwise direction only. As I said, in quadrantal system, it is with respect to magnetic north as well as south, whichever is closer from the line in the eastward or the westward. It means in the clockwise and the anti-clockwise direction for quadrantal bearing, right? Second difference is in terms of magnetic north line. It means here only one north line is considered as a reference line, while in quadrantal bearing system, north as well as south, both magnetic lines are considered as a reference line, right? Here we go for the clockwise direction only. Here the both clockwise and anti-clockwise is considered for the quadrantal bearing system. Again, the main difference is the whole circle, it means 0 to 360 degree, and a quadrant, it means 0 to 90 degree range of angle is achieved in quadrantal systems, right? While if I talk about different compass that we have learned in previous lecture, that is of prismatic and surveyor, I said that in prismatic compass a WCB system is used and in surveyor's compass a quadrantal system is used. It means my prismatic compass gives me the angles in the range of 0 to 360 and my surveyor's compass gives me the angle in the range of 0 to 90 degree. So that is the difference between WCB and QB system, right? Now let's go to the last one, which is reduced bearing. So now what is a reduced bearing? Generally, when the whole circle bearing of a line is converted into a quadrantal bearing, it means a circle is divided into a quadrants, right? That term is known as the reduced bearing. So I can say it is quite similar to the quadrantal bearing because its value also lies between the 0 to 90 degree, as the quadrant should be mentioned for proper designations, right? So here, if I want to convert WCB into RB, what are the methods or what are the equation for different quadrants I should follow? For that, a table is given in which the first column says the WCB of any line. It means, as we have discussed earlier, the first quadrant having the range of 0 to 90, second is having the range of 90 to 180, third 180 to 270, and last is from 270 to 360, having each quadrant's value for WCB. Now, when I talk about the QB, it means when I convert it into the QB, it is known as the RB. So the quadrant mention is in such a way that I have to write northeast, southeast, southwest, and northwest. Between that, whatever the value is, I have to place there so that I can bifurcate that if I write only 45 degree, it is denoted in WCB system. And if I write north 45 degree east, again the first quadrant value, but it is denoted or marked as a QB or RB system, right? Now, what are the rules for conversion? So here some equations are there. So here you can see for the first quadrant, as there is the rule are same with respect to north in clockwise direction for both the cases, RB is equal to WCB. So there is no need for an equation. But for the second quadrant, in WCB, what we do from the north, we go to the second quadrant. But in the quadrantal system, we go to the south to our survey line in anti-clockwise direction. It means the half portion make 180. It means I can say if I want to calculate the reduced bearing, I simply have to minus my whole circle bearing from the 180. It means the equation is reduced bearing is equal to 180 degree minus WCB. Next, for third quadrant, equation is reduced bearing is equal to WCB minus 180, because for third quadrant with respect to north, we go in such a way from here, right? But for quadrantal bearing, we are simply going to here from south to our survey line. It means I have to simple from my whole circle bearing to 180, I have to minus so that I can get my reduced bearing, right? And lastly, for fourth quadrant, it is a whole circle. It means from north, I go in the clockwise direction to my fourth quadrant. And the opposite, it means from north in anti-clockwise, I go to my survey line in quadrantal bearing. It means the equation is reduced bearing is equal to 360 minus WCB. For now, you please try to understand this, but you better understand it when you know the example of conversion from WCB into RB. Say for the example, the first is the 55 degree. Here you can see only 55 degree is mentioned. It is saying that this is the example of WCB, right? This is the right method to represent angle in WCB. Now, if I want to convert it into the RB, it means I am placing north, south, east, west first, where 55, it means the first quadrant. As you can see that my survey line is passing from the first quadrant having the angle of 55 degree. Now, I want to calculate the reduced bearing. Again, the concept is same from north in clockwise direction. So, the value is same, but method of representation is different, which is of north 55 degree east, right? Now, the second example is of 135 degree. It means in this second quadrant. So, something like this where my survey line is passing from the second quadrant having the value of 135 degree, right? So, it falls in the second quadrant. So, for second quadrant, we have discussed its equation that from 180, I have to minus my 135 to get my answer 45 degree. Because in QB, we know we go from the south to our survey line in the anti-clockwise direction. So, that is the concept of conversion from WCB into RB in second quadrant, right? Now, let's discuss the third example, which is of 240 degree. It means a north, south, east, west. 240 means the line passing from the third quadrant, right? And for that, the equation is WCB minus 180. It means the answer is 60 degree. But when I have to write it, I can write as S 60 degree W, right? So that is the way we can represent our angle in RB. Now the next example is of fourth quadrant, which is of 335. It means north, south, east, west is something like this. I have to draw my line which passing from the fourth quadrant. It means I have to provide the value in such a way that simply I have to deduct my WCB from 360, which gives me the angle 25. So this is the answer, right? But 25, I have to represent it in north 25 degree west way. So that is the example of conversion from WCB into RB, right? So that is all about the measurement of bearing in these three systems, right? So this is all for today's lecture, in which we have discussed terms which is most important, as well as the methods in which we are measuring the bearings. It means the angles, right? So I hope you all understand all these two topics in detail. See you soon in the next lecture. Thank you for watching. Don't forget to like, share and subscribe my YouTube channel Civil Edu Next.